welcome back to my channel, The Machining Maestro. Today I am going to explain you the profile turning operation. In a profile turning operation, the material is getting removed both radially and longitudinally from a raw cylinder to produce a part which consists of various radius, chamfers or some step turnings or some tapers over there. So from this isometric view, you can get the idea this slightly red color portion is going to be removed to produce a structure like this. And from this orthogonal view, you can get the idea that this red color hashing portion is going to be removed to produce a structure like this. So before going to create the program, we should have the positional value or the coordinates of these points, because the positions of these points are really necessary to fit in the program. Hence the program will follow these as a path to produce the structure for you. So let's calculate the points. So at the point number 1, since it is the starting position of the raw material, so at this point the Z value will be 0. I'm putting 0 here. Okay. The diameter value at the point number 1 has not been given here. So for to get the diameter value for the point number 1, we should consider the we should follow the point number 2's diameter. At the point number 2, the diameter is 10. Since the chamfer was given 1 mm here, the diameter value at the point number 1 will be 10 minus 2 into 1, meaning 2 multiplication of 1, meaning 1 mm from here, 1 mm from here. It means the diameter will be 8. So I'm putting diameter is 8 here. Okay. So again, let's calculate the point at the point number 2. The diameter was already given, so directly write diameter is 10. Okay, and the Z value will be at point number 2 is like minus 1, because the chamfer was given 1 mm here. It means the distance between point number 1 to point number 2 longitudinally is 1 mm. So I am writing down minus 1. Why minus 1? Because we are going in negative direction. That's why the value will be minus 1. Okay. At the point number 3, you notice there has not been any changes in the diameter, uh, but in length. So the diameter will remain same, but the longitudinal value or the Z value will be changed, and the value will be like minus 10, because from this chain dimension you can get the idea that the distance between the starting position of the cylinder to the point number 3 is 10. So I'm writing minus 10. So let's calculate the diameter at point number 4. For the calculate the diameter for calculating the diameter at point number 4, you notice there has not been any diameter reference value provided over here. So to get the reference, we should consider point number 5. At point number 5, the diameter is 28. Since there is a radius at point number radius is starting at point number 4, you should subtract this radius value in multiplication of 2 from the diameter at point number 5. So the diameter will be 28 minus 2 into 4, meaning 8 mm. So 28 minus 8 will be 20. It will be 20. So diameter at point number 4 will be 20. Okay, so the Z value, there has not been any changes. The Z value when the tool travels from tool number 3 to tool number position number 4. From the position number 3 to position number 4, there has not been any changes in Z, because it is going vertically. So the Z value will be same. So I am writing down minus 10. Okay. So at the point number 5, the diameter value is already given, which is 28. So I'm putting 28 here. But the Z value, for the Z value, you should add this 4 mm with the 10 mm, because the distance between this point number 4 to the starting position is 10 mm, and the distance between point 0.5 to point 0.4 is 4 mm, because the distance from here to here is 4 mm all the time. Okay, because the radius is given over here. So 10 plus 4, it is 14, so put minus 14. So at the point number 6, there has not been any changes in diameter compared to the point number 5. So put the diameter as it is, 28. So I'm putting 28 here. 28 here, but there has been some changes in Z. The change To calculate the changes, you consider the previous point. At the point number 7, the value of Z is 30, and since there is a chamfer of 4 mm, so you subtract 30 minus 4, which is 26, minus 26. Okay, so at point number 7, you at the point number 7, the diameter value is the diameter the diameter value at point number 7 is not given here. So to get the diameter value of point 0.7, you should follow the diameter value of 6, diameter value of 6. So at this point number 6, the diameter value is 28, and since there is a chamfer, you add this chamfer value in multiplication of 2 with the diameter of point 0.6. So 28 plus 4 plus 4, meaning 8. 28 plus 8, it is like 36. So the diameter will be 36. So the Z value will be like it has been already given, so you put minus 30. Okay, so similarly at point number 8 is not required because the raw material size is already given 40. So we are going to start the operation from the diameter 40. Even if you are mentioning the point number 8's value, no problem, you can provide. But even if you are not giving the point number 8's value, then also no problem, because we are starting the machining from the diameter 40. So it will of course remove the material starting from here. Automatically it will maintain the 0.8 to 0.7 distance, because when it is approaching to produce the point number 7, so that time it will automatically uh, produce the profile of 8. Okay, so the point number 8's value is not required. And let's go to the tool what we have used over here. The tool that says that the holder we have used over here, that is PCLNR 2525M12, and the insert used over there is CNMG 120408. So to get the tool data and to create the tool in the machine controller, uh, mm, let's go and create this tool and program. It is all about your tool data. This is the tool, and the black portion is the holder, and the yellow portion is the insert. The holder name is PCLNR 2525M12, and the insert name is CNMG 120408. And this is called the ISO designation of the holder, and this is the ISO designation of the insert. This designation has some meaning. So the meaning I have briefed you in the left side, and here is the meaning of this designation available here. The meaning of P is the clamping type, which is P type clamping, and there are already various kind of clamping. P is one of them, and the C is the insert shape or insert angle, which is 80 degree. The angle which is producing over here is 80 degree. The tool holder type or tool holder angle, the angle is produced between this surface and this surface is 95 degree. The insert side clearance angle is 0, which represents N. N represents the side clearance angle is 0 degree. The angle is produced over here is 0 degree. And R is representing the right hand cutting tool, and 25 is the shank height, and 25 is the shank width, and m is the total tool length, and toll is the insert cutting edge length. The length of this yellow portions wall, which is the cutting edge, the length of the cutting edge is 12, which is in mm. So this is all about the ISO designation of the holder. Actually there are many kind of holders and of their many kind of designations, many kind of designation meanings, which I will explain you in my coming videos, where I will take the example of many different kind of tools and their ISO designations, and we will discuss one by one over there. So just it is just a quick briefing for you to understand this tool, because this tool we are going to create in our machine controller, so that this tool can be used in the program and you can check the simulation properly. And now come to the insert data. The designation says C is the insert shape or insert angle, which is 80 degree. N is the insert side clearance angle, which is 0 degree. The clearance angle is produced over here, which is 0 degree. M is the grade of tolerance or class of tolerance. There are many grade and class of tolerance. M is one of them. And G is the fixing type or chip breaking type. The inserts are always designed with some chip breaking formula or chip breaking designs or fixing designs. There are many kind of such designs. So G is one of them. And 12 is the cutting edge length. 12 is the cutting edge length in mm. The cutting edge length is the length between the two adjacent sides of the insert, which is 12. 4 mm is the thickness of the insert, and 0 it is the corner radius or nose radius, which is in mm, but 0.8 mm, not 8 mm, it's 0.8 mm. So you see the CL12, C1208, these are I have highlighted in red color letter. So these are the information which we require to create the tool in our machine controller. So let's go and create the tool over there. Thank you. This is your machine interface. We are going to create our new tool. For creating new tool, you go to offset, and in this window you see there are already many tools in your tool list, and they are situated in different magazine locations. You can see from here. So if you want to create a new tool, actually there is two type of method. Maybe you can delete this tool, or maybe you can unload that tool, and at that position you create your new tool, or else you can create your tool at any empty position. But if your turret is having 8 number of tool stations, then you can use the location up to 8 only. If your turret is having capacity can carry up to 12 number tools, so you can use your location up to 12. So meaning in my case, I'm going to create my tool at location number 1, for example. So that's why I will delete this tool, or else I will unload this tool. So for unloading this tool, you click unload. So while unloading, the tool is getting placed at the bottom of the tool list. So later you can load it to any position or any location position you want. But for deleting any tool, you just click here and press delete. So after pressing delete and clicking OK, the tool is getting disappeared completely. The tool is not available for you anymore. So these are the two cases. So if you want to load this one, you click here and press load. It is asking in which location you want. So you can give 9 to anything. So I'm giving 9 number, then or maybe 10 number. So you see that in 10 number there is no tool available. You press OK. The tool is now at location number 10. So in this way you can load unload your tool. Loading is a good option, because later you can use that tool, and the parameters will remain same. All you need to change your offsets only. Offset meaning the references only. So at the position number one, location one, I'm going to create my tool. For creating the tool, you click on new tool, then choose your tool. Our tool is the roughing tool because PCLNR is a roughing tool. And out of these cutting edge positions, you select the first one, then press OK. Then give your tool name. I'm giving PCLNR 2525 M tool. Then press input. So after pressing input, the sister tool and the cutting edge position, these two are become one and one, because there is no such tool kind of tool is available in your tool list. If you find any PC Lena 2525 M tool, same identical tool over here, the sister tool become two. But since only one tool is over here, that's why the sister tool is only one. And D is the cutting edge position, cutting edge number or cutting edge position, that we will discuss something later. All about this tool list creation and detail tooling part, we will discuss something in my later coming videos. So there I will explain you everything in detail, but here I am giving you just for giving you such some idea, just for a example, because without creating your tool you cannot check your simulation in your machine, or else without creating the tool you cannot run your program. So the parameters are really important. So I'm showing you how to store the parameters here. So the sister tool gone, the cutting is gone. Length x, length z. Length x is the distance between of your tool to the diameter of the workpiece. So when you take the references, when you take the offsets, that time the values are automatically getting stored over here. And in case of z also, it is the distance between the workpiece face to the tool. So these two are something you will get, or it will be automatically restored when you take the offset. So since we are not doing any practical over here, I'm just putting some random values like minus 200 and minus 300. Okay. So in the radius part, that is something we got to know from my previous slide, where the nose radius I have told you it's 0.8. So you write down 0.8, then press input. Then this is the cutting direction. So out of these four, you choose this one. Okay, if you want to look for the option, then you go here and press select. So out of these these four options, you select this one, then press input. And this is the column where it is asking for the holder angle. The holder angle I have already told you, that is 95. Then write down 95, then press input. Then the next column, it is asking for the insert angle. Insert angle is also 80 degree here, so you write down 80 and press input. Then it is asking for the plunger length. Plunger length is nothing but the cutting edge length. So cutting edge length you keep 12, because in our tool the cutting edge length is 12. So press input. Then it is asking for the spindle rotation, but this is not a this is not a milling machine, or this is not a ton mill. So that's why the spindle option meaning doesn't matter. So keep it as it is, and go for the next option. Then it is asking for the coolant, and 2 is the dedicated coolant. So coolant is also, even though you click it on, you have to write the um, coolant on program in your full program. So if you want to turn it on and turn it off, that is up to you. And similarly, the coolant number 2 is something that if you turning it on, then if you have some dedicated to coolant supply option, then that will be turned on. So from here to here, like from this length z, radius, the cutting direction, holder angle, insert angle, and the insert cutting edge. These are something the really important parameters. And length x, length z is something are getting stored automatically when you take the offsets or the references. So radius and cutting edge direction, holder angle, insert angle, and the cutting edge length, that you need to get the data from your tool and put it here, so that your simulation will be very proper for you, and you can visualize your mistakes or visualize your proper machining process in the simulation. So next we are going to show you how to uh, create the program. Now we are going to create the program. So for creating the program, press on this program manager icon and you select the part programs. To check the available programs in this part programs directory, you click on this plus icon. Already three programs are there based on what we have created our past videos. So here we are going to create the program. So creating a new program, click on this new icon. Now define the program name. I'm defining the program name, profile turning, then press OK. So this is the program interface, and the first task is to create the workpiece. To create the workpiece, press on this various icon, then you click on this blank. So here we define the raw material dimensions. So our raw material type is cylinder, and XA is nothing but the diameter of your raw material, which is 40. You write down 40, then press input. Then ZA nothing but is the starting point of the starting Z value of the cylinder, which is 0 all the time. I'm keeping 0, then again input. Then ZI is nothing but the total length of your raw material, which is as per drawing 55. So write down minus 55. Why minus 55? Because we are going in negative direction. ZB is nothing but the material we are keeping for the machining. Since our machining is required up to 30 mm, up to minus 30 mm, so we should keep the value more than 30. So minus 35 is okay. Anything you are keeping more than 30, more than 30 is okay. So I'm just putting minus 40. Okay, minus 35 is also okay. Now press input, then click accept. So the workpiece has been created. Then press input, then you write down the pre-operation command. The first pre-operation command will be G90, which is the activation of absolute mode. Then G71, it is activation of metric mode. Then Z95, which is feed in mm per revolution. Then Z64 is the activation of continuous path control mode. Then press input, then you write down the homing command, which is T0 D0, then input Z0 X0, input Z0 Z0. Okay, then we need to call our tool. To call our tool, you click on edit, then select tool, then you select our tool number 1. Like if you would have to select the tool number 3, you select here. If you want to select the tool available on location number 1, you click here, then click OK. So the tool is automatically got called over here. So then click input, then you turn on your spindle. I'm turning on my spindle. M3 S700. M3 is the spindle rotation clockwise, and S700 is the RPM of the spindle. Then I'm calling my tool to the safety position before approaching for the machining. So the safety position will be G0 Z2.0 input, then Z0 X 42.0. Okay, then press input, then turn on your coolant, which is M7. Okay, so after that press input again. So now we are going to create our required cycles. Okay, so to create the cycles, you click on this contour turning, you click on this contour, then you click on this contour call. So in contour call, you define the contour name. I'm defining the contour name as profile. Okay, then press accept. So we need to call the contour here first, then click input, then you click on back, then you click on stock removal, then you select the input, which is simple or complete. We are selecting simple. You define the program name as it is profile, like the contour name we have given in our previous cycle. The same name you have to provide here. Okay, so the feed rate I am defining here 0.2, which will be 0.2 mm per revolution. You can define 0.15 or 0.3, anything 0.3. Okay, then input, then machining type. From machining type I'm selecting roughing, and these three options are like roughing, finishing, and roughing plus finishing. So I'm selecting roughing only. Then this is the machining direction. Machining direction is longitudinal or face or contour parallel. I'm selecting longitudinal because in this operation the tool will travel like the graphical image you see here, or the graphical video you see here. Okay, so I'm selecting longitudinal here. Outside, this is the positioning of your workpiece, meaning like if you want to do the external turning operation, you select outside. If you want to do the internal turning operation, you select inside. So since I are doing the external profile operation, so I'm selecting outside. And this is the tool travel, tool direction. So if you want to get the options, you select here, you will get the options. So since our directions are always like in negative direction, so in this direction, approaching from right to left, so our directions will be like this. D is the incremental depth of cut. You see the D value here. So I'm giving 0.2 or 0.3, anything you want to give. So I'm giving 0.3. So the total depth will be achieved by this incremental depth of cut, meaning the in one path, in a single path, it will cut 0.3 from the diameter. Then in the second path again it will cut 0.3, like that incrementally the value will increase and to achieve the final dimension. Ux is nothing but if you are keeping any allowances, if you are leaving any material at the periphery, at the diameter of the workpiece for the finishing cycle. So I am putting 0.2, you can put 0.1, then input. Uz is again if you are keeping anything uh, on the wall of the workpiece or in the longitudinal direction of the workpiece, so you keep here uz value. This is required for for the finishing operation, or to maintain the length, or to maintain the profile structure. So we are keeping the allowances. So again I'm keeping 0.1, then press input. So it is asking the blank description. The blank description is cylinder. So we are cutting the material from a raw cylinder. That's why selecting cylinder. So it is asking XD. XD is nothing but the raw material size. What is the raw material size right now? The raw material size is 40. So I'm putting 40. Then press input. ZD. Z is the starting length of your workpiece, which again I'm keeping 0 because the starting length is 0. So I'm keeping 0 here, 0, then input. Then a relief cut is nothing but if you want to cut this inverted kind of profile, in that time you need to turn it on. So we don't have such profile over here, but still if you are keeping this on, then no problem. And this is the feed rate while doing the relief cut operation. So this feed rate is unnecessary here, but if you are keeping this also, then no problem, because if you are keeping this zero point 0.1 and or zero point 0.2 anything, so that will impact when the tool perform this inverted profile operation while plunging over the workpiece in between the diameter, in between the radius or in between the length of the workpiece. So that time plunging feed rate is really necessary. So to reduce the plunging feed rate, there is option available. The feed rate available over here, this is the feed rate for the longitudinal, all the longitudinal operations. But this feed rate is the when the tool starts plunging over here, no. So that time feed rate needs to be controlled, because the tool is directly plunging over the diameter of the workpiece. So that time the impact will be higher. So that time you need to reduce the uh, plunging feed rate. Okay, so that's it. Then press accept. Then you write down, then you press input, then you write down the post operation commands, which is G0 Z2.0, pulling out my tool to the safety position. Then I'm writing down M5 M9, spindle off, coolant off. Then I'm writing down the homing program T0 D0 input, G0 X0 input, Z0 Z0 input, then again M30. M30 is the program end. So next you you click input, then you you have to create the contour. Contour is nothing but the profile, the path we need to give, the path's information we need to give here to the program. Hence it will follow the path and will create a program for the profile. Okay, so to create a contour over here, so you click on this contour icon, then click on this new contour. You give the same name like profile, the same name you have to repeat here. So I'm giving the same name, pro profile, then click accept. So here comes the main task that we have to provide the values over here. So this is nothing but the starting position value, the point number one, the value of point number one over here. So the value of point number one is the diameter is 8, and the z value is 0. So you put 8, then input, then put 0, then input, then you click accept. Okay, so the point number one is created. So let's go to the point number 2. So we are traveling point number 2 in a direction which consists of both vertical and horizontal movement, that is a chamfer. So for that you select this option. I'm selecting this option, and here the x value will be, at the point number 2 the x value is 10 and the z value is -1. Okay, so click import, then click accept. So the chamfer has already created. See the coordinate value is 10 here, and the coordinate value 8 here in diameter, and the coordinate value is 0 and -1 respectively in z direction. So for the from the point number 2 to point number 3, the travel is in longitudinal direction. There is no travel in radial direction. So that's why you select this one, and you put the z value at point number 3, which is -10. Then you click input, then click accept. Okay, so at the point number 4, let's go to the point number 4. At the point number 4, there is some changes in diameter, but not in longitudinal or in z direction. So you select this one, and you put the x value over here. From the table the x value is 20 here, then put 20, then input, then click accept. Then for the point number 5, there is a radius from between point number 4 to point number 5. So to create a radius, you select this option. Okay, so direction of rotation, it is asking the direction of rotation. There are two kind of rotations. You click on the select to choose. So one is like this, one is like this. So our rotation is like counterclockwise. So we have to select this counterclockwise option. Then you provide the radius. The radius value is 4 mm, and the x value from the table is 28, and the z value is from the table minus 40. Okay, so it is asking to select the dialog, meaning by keeping the radius value this, there are two kind of arc can be formed. So you have to select out of these two to ensure which one you want in your path. So since this has got selected, so you select the you see accept the dialog. If you want to switch between the dialogues, you click on this. So it is selecting this one now. So if you click again, it will select this one. So after selecting this one, you accept this dialog. Okay, then again you click on this accept. Okay, so the radius has been created. Okay, so the point number 5 is gone. So next, point number 6. So the travel from point number 5 to point number 6 is longitudinal, so we are selecting longitudinal. So we are just we have to just put the z value over here. So at the point number 6, the z value is minus 26. Then click accept. Okay, so the point from the point number 6 to point number 7, there is a taper movement or movement of chamfer, the chamfer value of 4 mm. So for the movement of chamfer, you click this and you put the x value at point number 7, which is 36, and the z value is minus 30. Then you click accept. Okay, so the chamfer has been created, and this is all about the profile. If you want to create the, if you want to give the point number 8's value, then you can give. If you are not giving also, then no problem. So that's it. And the machine will automatically create this profile by uh, by machining. So we will check that in the simulation. So click accept here. So the contour has been created. So from the simulation now, we will able to see the profile creation. So click on this simulation part. So click on this simulation. So I'm clicking on this 3D view. So see, the tool is coming and it is cutting the material longitudinally uh, from the mm, from the periphery of the cylindrical raw material to produce the profile as per the points we have given to the machine program. So you see from here, it has created the chamfer, and also it has created the radius, and again it has created the chamfer over here. So from the side view also, you can get the idea that we have the goal up to minus 30. So it has maintained the length up to minus 30. Again, the first step's length was up to minus 10. It has maintained the length up to minus 10. Similarly, diametrically also you can check the diameter by zooming in proper, like the diameter at this point is minus 10, it's 10, and at this point is really like at this point, see, it is like nearly 28. Why not 28? Because we have kept the allowances of 0.1 or 0.2 over there. So that material was kept over the diameter of 28, over the diameter of whole profile, to remove that material in the finishing operation. So that is all about your profile turning operation. So coming to some of the controllers, from the programming controller, you can regulate the speed of the simulation, regulate the speed of the simulation. And also in from this detail button, you can select the zoom in, zoom out options, and like that. And from this side view also, you can see, check the side view directly. And from the further view, you can check the half cut view also. This is the sectioning view also, you can check. So that is all about your profile turning operation. So thank you very much for your attention. So in our next video, I will tell you how to create the drilling program. And in our coming videos, uh, we are going to teach you the internal machining operations. So thank you very much.